In episode 30 of the SOC Level 2 training series, we are going to go through the Atomic Bird Goes Purple number 1 challenge. And this is essentially a series of capture the flag exercises that we're going to be doing using the tool Atomic Red Team and Atomic Test. And these were the ones that we did not in the last episode, but the episode before that. So the last episode prior to this one is going to be Caldera. And right before that, we were working with Atomic Red Team and then using Atomic Test to run a series of threat emulation exercises. And this is all a part of the threat emulation module inside of the SOC Level 2 pathway of TryHackMe. So as a part of this specific exercise, we're going to be going through obviously the introduction, reviewing what threat emulation means to us, getting started with custom exercises and the investigation process, because they've actually created some custom tests that we can run that are outside of the MITRE attack framework series of tests. So if you remember, if you watched the Atomic Red Team video, we were using a lot of MITRE IDs for the TTPs, the tactics, techniques, and procedures. We were using actual IDs from the MITRE framework, from the MITRE matrix, to run our tests. But in this particular case, I think they've created some custom tests for us. There's Toolsets and Hints, Execute, Investigate, and Detect, Universal Suspicious, Share, Dump and Go, and then finally the conclusion, and then we'll do like a review. I'll give you some final thoughts, and then you will be dismissed for today. So that is pretty much the overview of this exercise room that we have, which is the Atomic Bird Goes Purple number 1. It's like a very long-winded title for this video. If you're serious about your CySec training and want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the Supporter, Agent, Guardian, and Master. Each tier gets their own Discord server and early access to content. The Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. Now, without further ado, let us jump into the Atomic Bird Goes Purple number 1 room. To start it all off, we need to go through the recap of threat emulation just in case you skipped all of that stuff. So the bottom line of everything that we've done is to enhance the impact of the purple team. The purple team is a combination of the red team and the blue team, hence the color purple. And inside of that team, for the activities of that team, threat emulation and detection engineering exercises are implemented, and you do this to go beyond the defaults and the basics. And what we're going to be doing in this video is real life scenarios using the outcomes that we gain during all of those modules or the exercises inside of that module. And we're going to emulate and hunt adversarial tactics and experience purple teaming type exercises. The objective is to gain hands-on threat emulation experience, familiarize ourselves with the artifacts created by adversary tactics and techniques, experience emulation and detection to improve the overall security defenses. And some of the prerequisites would be to understand Windows event logs, to understand Sigma rules, SysMon, Aurora, EDR, the endpoint detection and response tool, hacking with PowerShell, which is a very basic room about just PowerShell scripting and just understanding how PowerShell works, and Windows fundamentals. And every single one of these actually already exist on this channel. So if you've never gone through any of these, or if you don't know what Sigma is or how it works, or if you don't know what SysMon is, I would recommend you go through those prerequisites, because for the most part, I'm not going to be explaining the finer details, the foundations of these things. We're going to be using them to try to capture the flags and try to find the answers to the questions. But if you don't know what we're doing and you don't understand the fundamentals, you're probably going to have a hard time wrapping your head around everything that we're going to do today. So before processing to this task, I'm going to start a virtual machine, which I've already done. And this is what we see right here. We have a Windows machine that has been assigned to us that comes pre-installed with everything that we would need to get the exercises done for today. And that's pretty much it. So that's it for the introduction. Now let's talk about getting started with custom exercises and investigation processes. Threat emulation, if you don't remember or if you don't already know, is essentially the idea or the concept of emulating a threat or an attack that has happened against a company or a country. And this is done through simulating and replicating those specific tactics, techniques, and procedures. And as I mentioned at the beginning of this whole video, previously in the previous videos, we were using the MITRE IDs, the MITRE attack IDs, to retrieve all of these things. So I've been doing this a lot lately. It's literally my #1 search in my browser here. When you go to the MITRE attack framework, which is this right here, the attack matrix we have right here, and you go over any of these things. If you go over any of them, you'll see that there's this, when you hover over it, there's an ID that pops up, TA0004. And then if we go under it, we have T1548. And then if I open this, there will be T1548001, 002, etc. So these are the IDs, right? Previously, in the previous video that we ran for Atomic Red Team, we were actually using actual IDs from the MITRE attacks. Now, in this particular case, what we're doing is most likely, I believe, we're going to be using it seems like we're actually using the same types of techniques, it seems like, because we have, base tactics is TA002 for execution. So if I go to execution here, it is actually TA0002, although they have 2 zeros. So TA002 is what they have. In MITRE, it's actually TA0002, and then the reference techniques that would be underneath them, so on and so forth. So it seems like we're actually still using the MITRE attack techniques, and that's what it seems like. I'm not sure yet. We'll find out in a little bit. The whole purpose of this entire concept of threat emulation is to recreate all of these attacks so that the blue team will learn from these attack emulations, and then if there are any gaps or weaknesses that are revealed, they will go ahead and patch them and make sure that we harden our security posture to have a better security posture as a whole. And so it contains a customized version of these atomic tests. So I knew it. So it's not the actual atomic test. We have the customized version of the atomic test to help us understand implementing purple team exercises with atomic tests and familiarize ourselves with the sample attack chain. So this is kind of the mapping of how it works. So the base tactic is actually TA002 for execution, when the real one is TA0002 for execution, and then it would be 0007 for discovery, 0009 for collection, etc. And then these would be the reference techniques that would be used, and the implemented actions for this one, for example, would be system enumeration. This one would capture the inputs, and this one would execute commands. And then we have the lateral movement, and this is done for finding new user accounts or potentially finding new credentials, and maybe even escalating privileges, which would be done the data manipulation on shared files. That would be the actual activity behind the tactic, the atomic itself. And then, of course, we have the collection of data that can be done through data dumping, clipboard, and system file modification. And this would be the ID that would be used for referencing it. So the process of this, the mindset behind this process is that the configured endpoint, if it is done correctly, it'll generate sufficient log files for threat emulation tests, and additional detection tools also increase the visibility, and various options for those tools exist. So Aurora EDR is what we used in the last video for Caldera, and Sysmon as well. We were using the Windows Event Viewer to access those events inside of those logs, and you can get a good amount of information by looking at your Sysmon logs or your Aurora EDR logs, and they increase the visibility of each test and enrich the logs. The purpose of the exercise is to view the results of the test as they are, and to observe the activity details and artifacts, which are crucial, obviously. I'm going to highlight this because it's in black. I don't know why they do that. So we're expected to execute given custom tests and then investigate logs and system activities for each test. The most important outcome of the exercise is executing a test and following up on the actions right after it. So this includes log, directory, and registry investigation. And we must consider everything from both red and blue perspectives to go purple, right? So finding source code to analyze malicious files or attacker tactics and techniques is not always possible. Experimental testing is one of the most common methods to overcome this challenge. Therefore, some atomics are not provided in clear text, but task descriptions and event logs provide sufficient information to understand what to expect from each test. So this is the general overview of what we can expect from the exercises that we're going to be running today. So let's go ahead and look at the tool sets that are provided to us and the hints that we can use. The tool sets themselves are Windows Event Viewer, Registry Editor, Custom Atomic Red Team module, THM Utils PowerShell module, which is like customized commandlets essentially that are designed inside of the PowerShell of this machine. And then we have PowerShell itself as the tool. So the big hint here is that atomic tests are based on PowerShell. So each time you execute a test or use a module, the system will generate a considerable amount of logs. You can clear the log files before each test so that the log files are not cluttered throughout the exercise. Thusly, that's a great word, it will be easier to investigate the logs and detect the test results. So these are some of the commandlets, right? So these are the ones that are available through THM Util. So log clear all will essentially clear all the logs in the system. Log stats all will get application security system and PowerShell logs for us, and PowerShell operational and SysAdmin log stats. Log stats application will get summary of application logs, nothing in Aurora. Log stats Aurora will actually get us all of the Aurora agent logs. Log stats flag will give the flag for the question. So this is an interesting one right here that previously I've never actually seen before. And I believe once we run a certain test, a flag will be generated and we'll have to run this command to retrieve the flag. And then log stats PowerShell will get all the PowerShell logs for us. Log stats PowerShell operational will get the PowerShell operational logs. Logstat security will get all the security logs. Logstat sysmon will get all the sysmon logs, and system will get all of the system logs. So we can get individual logs like that. We can clear all of the logs as such. We can retrieve all of the logs together like this, and so on and so forth. So very simple, kind of straightforward series of commands here. These are it's kind of like an overview of what it's like to run a series of commands with atomic red team. Now, there could be invoke atomic red team, or it could be atomic test, and everything that we've done in previous videos has been invoke atomic test. It doesn't say that I have to configure it. In the last video, I actually had to configure it in order for it to be able to run. So the first thing that I'm going to do right here, I don't know why it keeps saying I have a connection error. I really hope I don't have an actual connection error. Okay, very good. So the first thing that we can do is just see if we even have the atomic red team or the atomic test actually available for us. So that's kind of the big one right here. And we even have it right here. So we actually have atomic hints right here on the screen, where cleanup artifacts would be this and etc. So these things are nice. So it seems like it's already available to me. So if I do help invoke atomic, whoops, what did I just do? Atomic test, it should bring the help menu. Okay, if it brings the help menu, that means that it's installed. So I'm very happy about that. And let's clear the screen. And so we have our PowerShell ready to go. Atomic test is ready to go. All of our THM commandlets, I'm assuming, are all ready to go as well. And running a test is very simple. So if you do invoke atomic test and then you give it the test ID number, you can do show details brief, where it will give you just kind of like the headlines of each of the tests and what they would do. If you do show details, it'll give you everything about the test, including the type of commands that would be run, what would be run for the cleanup, etc. And then this would be running the first test inside of this overall test series. So it says it executes the first test case of that technique. And then this would be the cleanup of that. And a good practice is to just clean up after every time you run something. Even if there are no files that are generated, you always just want to do a cleanup so that it deletes whatever potentially may have been done in the background. The PowerShell profile is customized to load required modules and provides atomic usage hints as shown below. The THM Utils module helps summarize important log files by grouping each event log based on the 4 categories: sum count, event ID, task category, and event provider. And so we see these hints. As soon as I opened it, you saw it in the bright green. And then THM log stats all will bring the important log statistics, for example, that there are this many events inside of application, 26,000 events inside of security, and so on. And then THM log stats application will bring everything for the application log. And of course, it's going to be hundreds of records that will be pulled up. So we need to feed that into some other kind of customizer. Now, one of the things that I'm really interested in is if I can actually just use the event viewer, because in my humble experience, it's just so much easier to go through the event viewer and use the event viewer instead of using something else. So we have the event viewer here, and then if we wanted to go to the application logs for Aurora, for example, we can click on Windows logs. We would go to application logs, and it's going to bring everything here. And then what we can do is we can go on the right side here and we can filter the log. And as the event source, we would just choose Aurora agent as the event source. And then that way we can only just see everything that has to do with the Aurora agent. And there's a lowercase one always and an uppercase one. So I'm just going to choose both of them and then go here, click OK. And there we go. Now we only see all of the events that actually have to do with the Aurora agent. So that's one way of doing it, which in my opinion is the preferred method of doing it. And another one is to go to application service logs, go to Microsoft, and then go to Windows. And then inside of this long list of services that pops up, we want to go to S and get to the Sysmon series of logs. And then inside of that, we have the operational logs. And inside of this, we get to see a bunch of different events as well. And things like the target file path and all of that information is available here. We won't be able to get a target file path from the Aurora logs. From the Aurora logs, we'll be able to see, a match string value of what triggered that event to pop up, right? And we'll be able to find some decent information from those logs, but the real details, like the really, really nitty-gritty details, is always typically available inside of the Sysmon logs, including all of the Sysmon log IDs, which are very, very important. And these are the official IDs for creating a new process or a file that was created and going through these things. Registry values was set, etc. So those are very, very important details to kind of think about as we go through all of the tools that are available to us. So what do we have here? We have use the required PowerShell command to retrieve the flag. What is the flag? So I haven't been told to run any tests so far. So if we're not running any tests, technically, all I would need to do is just run that one command. It was the thm retrieve flag, and really see what it is. So it's the thm logstats flag. So let's actually go into PowerShell real quick, and let's see if we can actually get a flag here. So it's thm dash logstats like that, and then do flag and run that. And so thm emulation is fun, but needs focus and exploration. So there it is. And then you do that. And then I just do Control C to be able to copy these things, because when you do right click on it, for whatever reason, it doesn't really work. So there you go. That's the first flag that we got. And what is the required command to clear all generated artifacts and restore the affected files from test T0123-4? So it's invoke atomic test, okay? And then you do T0123-4, and then you do dash clean up, and then you do that, and there we go. We got that, and that's all good. Ready to jump into the actual investigation here. So the first case that we got. For this case, our reference techniques are the T108.2 system information discovery and T1056002 for input capture through the graphic user interface. And I mean, the storyline, in case you're curious, is that the purple team aims to simulate system discovery, GUI prompts, and command execution. As a team member, your task is to discover the clear text credentials, create accounts with given custom atomics, and evaluate the generated artifacts. The objective is experiencing the impacts and artifacts of system discovery, user prompts, and command execution. The planned tests for this case are this one right here. So 0041, 0042, and then 43. So those are our tests. And I guess that's basically it. And then we have just like these questions for this. So it says execute test 0041 and open the document created on the desktop. What's the OS build info? And then 0042 has the flag. And then 43 is examine the logs. What is the failed command? So I don't need to look at logs. It seems to be for these ones right here. I just need to get the artifacts. And then for this one, what I'm going to do is before I run this test, I'm just going to clear all of the logs to only show the stuff that happens when we run this test. So that way it's a little bit easier to navigate through all of those logs. So the very first thing is to execute test 0041. So as like a good practice, what you can do is when you go into PowerShell, right, you can always just kind of get the information about anything by simply doing invoke atomic test and then do T0004-1, and then you can do this, right, show details. And then I'm not going to do brief because I actually want the full details. So this is it. This is all the details for this test. So we have 004, and this is initial enumeration. Then the test number 1 is the basic Windows enumeration. The executor is going to be PowerShell. Elevation is not required. And this is the command that's essentially going to be run when we run this test here. And this will be the cleanup command that if we wanted to manually clean it up, we would do this, but we can always just use the cleanup command to get it done. So this is basically it, right? So system info, find the string for hostname, etc., 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 and then it's going to create a document for us, which is called the task result.txt on the desktop. So does it ask for the name of the file? No, it just says open the document and then what's the OS build info. So let's actually go ahead and run the test, right? So very simple, same thing, invoke atomic test and then T, we're doing 0041 like that, and then that's it, just run it. And then so it runs, and then it's going to take however long, and then it'll complete, and then there we go. And so we have the completion that's done, and anything over here that we can use? Nothing over here. So what we're going to do is we're just going to go to the desktop and we're going to look at this task result right here. And it says the build info, right? That's what they want, is the OS build info. So OS version, etc., etc. I would assume it's this whole thing right here. So 10.0 yada, yada, yada. So we're going to copy that, go over here, and we're going to paste it. Boom. That's the first answer. Cool. Now we can run the next one, 10.004-2. So I'm going to close this and I'm just going to delete this file because I don't like extra file. I think I have like a minor case of OCD because certain things I'm like, dude, it needs, just get it back to normal. I don't want it to look the way that it was. Okay, so invoke atomic test T and then 0004-2. And then I'm just going to do this every time just so we can get some kind of idea here. So atomic can be used to prompt messages and forms to fill out. PowerShell command is basically this PowerShell script that's inside of the atomics location of the atomic red team, yada, yada, yada. So let's do this. Invoke atomic test T 1, 2, 3, 4, and then 2, boom, and it's going to run. And, ooh, interesting. This is anomalous. THM emulation room username and password. So what does it say? It says what's the flag? So THM underscore emulation underscore room. That would be it. So THM and then squiggly THM underscore emulation underscore room squiggly. Boom. There's the flag. Nice. Okay, cool. Now for this one, we need to actually examine the logs. So what I'm going to do over here is I'm just going to close this thing because I really don't need that. Oh, you know what? I see the thing that I was just talking about, I didn't even do. So I need to do T0004-1, and then I'm going to do cleanup because I didn't do it last time. So I want to clean up everything for that real quick. And then I'm going to do the same thing for -2. See, that's the thing, right? Like you have to listen to your own advice. Oh, I just ran the freaking test again. Goodness gracious. Okay, cancel that. And just press up and then do -cleanup like that. And there we go. Let's clean that up. Okay, great. Cool. So we did the cleanup for both of those tests. And now what we need to do is I'm going to open up the logs right here. And right on this side right here, beautiful little button, clear log. And then it says you can save the contents before clearing it. I'm just going to clear the log. So that's what it is for the operational. And then we're going to go back to application right here. And we're also going to clear the application logs. Now, when you do this, there's always an event that's generated because we cleared the logs. That's going to say, you know, a security event was generated because somebody cleared the logs, which is like a big thing. It's like, why are you clearing logs? So when you clear the logs, the Sigma rule for logs that were created goes off, and Aurora is like, hey, you know, pay attention, somebody just cleared the logs. But I did that myself. So the first two events, usually when we run anything, the first two events are associated with the activity that I did where I cleared the logs. Now I'm going to run the third test and then examine the logs, and what is the failed command is what it says. So I'm going to do invoke atomic test, and then just for the hell of it, right, we're going to look at what it actually is, and let's see what commands it's going to run. And so it says start process PowerShell argument list window style hidden command bin bash. So I'm just going to assume that this would be the command that was failed, right? So it's either this command that was failed or start process, but I don't think it's that command. I think it's literally genuinely, I feel like this is the full command that was failed. So I'm just going to copy this and go ahead and use it. Yeah, so that was the answer. That a lot of times you can just get the answer by looking at the details of the thing, but just for, you know, just for giggles, right, just for shoots and giggles or whatever, I'm gonna run the test, and then we're gonna go ahead and look at the details that were generated inside of our logs here. So let's go here, let's refresh the logs that were generated here. Oh, come on. So are you telling me that none of these things actually have anything that's generated? So maybe we literally have to use, oh, there we go. See, some events were generated here. Okay, that's fine. I was about to say, bro, no way. Like, no way that no events were generated. That's insane. How is that possible? So hostname.exe and whoami.exe are usually the first two that are generated. So you can always kind of just ignore those and then start going for everything else that would potentially be of note and looking at what was technically ran. So cmd run, and then we can just kind of go through all of these things to try to find the information. So I'm going to scroll this up a little bit just so I can see the command line detail. And then from there, I'll try to see if I can find the actual event that has that one item that we're looking for. So hostname exe again, whoami exe, and we'll go through it. Boom, here we go. So PowerShell exe bin bash. This is the one that was ran, and the administrator is the user. Let me see. It's a PowerShell executable as the parent item, the image, which is important to note. So there's a few things that are of note here when we want to look at what's going on. And then we can see atomic, well, I think atomic bird is actually the host name, so that's kind of irrelevant for this case. All of them are most likely going to have that. So that's it. That's pretty much it. This is the command that was executed that failed, that was not able to run. So we have another one right after this that actually ran as well, which is the PowerShell script that was attempting to create a file, and another one which is another DLL file that was trying to run here, that was trying to create, and then a command line. And what else do we have here? A command line that is using the temp, let's see, CMD lines, that same file that was actually created in the previous exercise, machine, output. Yeah, none of these things are really of note at this point. Seems like the only thing that was really of note was that one command line that was ran, and then it was attempted to run yet again, and we can see that over here as well. So there we go. That's the answer inside of the logs. You can actually see it inside of the logs, and it says over here that there are even new events that have been generated. So I can refresh it, and there is one last event that was generated at the very, very top, and the command line for that was the svc host command that ran. And let's go back to the top just in case. I mean, it feels so silly that there's no application logs that were generated. That kind of makes me wonder whether or not we even need to use the event viewer. But I mean, we got the answer by looking at the details of the test, so that part's kind of silly. But I'm gonna go back over here and I'm going to press up on my keyboard to bring up the last command, and I'm just going to do dash cleanup to make sure that we actually clean that up. And now we are ready to go to the next one. So we will clear the screen, and then let's go to the universal suspicious share. The reference technique for this one is T1091, replication through removable media. And the storyline is that the purple team wants to simulate file manipulation actions on shared drives or files. As a team member, your task is to manipulate the shared files with given custom atomics and evaluate the generated artifacts. And the objective is to experience the potential impact of file manipulation, becoming comfortable with executing commands and analyzing the results. The test that's been designed for us is 0005-1 for universal suspicious share, and we can revert the system modification and file change activities by using the cleanup command of the executed technique, which we will do because we are professionals here and we know exactly what to do. Okay, so navigate the disk and drives and open the shared folder. What is the SHA-256 value of the TXT document in the shared folder? What's the hint here? So suppose you simulated the attack before obtaining the hash value of the document. In that case, you can revert the document to its original state by doing the cleanup function of the test. Okay, that's fine. Execute the test 001 and then recalculate the SHA of the document. I see. So we're first trying to find the shared folder, and then from there we're going to look at the SHA-256 value of the text document inside of the shared folder. Then we're going to run the test, and it's going to modify that text document, I'm assuming, and then we're going to recalculate the SHA-256 value of that document and see what the new hash value is going to be. So let's go and find the shared folder real quick. Okay, so I'm assuming that's it. It says share for all. It's so obvious. So this is it. This is the file right here, donation call. So if I do right click here, can I open up a new terminal inside of this location? I can't open up a new terminal here, but okay, so we're looking at the share for all inside of this PC, and the text document is inside that. So we're going to do this. Let me zoom in so you can see what I'm doing here. So this PC is technically the C drive that we see right there. So I can just do that, and I'll be inside of this, and then I can do ls because I'm inside of PowerShell. If I was just inside of the command line cmd.exe, you would have to do dir, but inside of PowerShell, both of them work. And then so inside of this, we see users, atomic red team, etc., etc., etc. So this location is this PC. So let's see what the full location of this is let's see, desktop. Can I see the full path? Let me see. It's the S, I see. So it's actually not even C. It's the S drive. So it's not local C. So what we're going to do is we're going to CD into the S drive like that. There we go. So that works. So now we're inside of the S drive, and then we're going to do dir, and then we can see that inside of this we actually have the donation call. So now we need to run the command for getting the, what is it, SHA-256, right? That's what they asked for. So I know that usually I wonder if it works here too. So if I do SHA-256 sum, this is available in all Linux and Unix operating systems. I really wonder if it actually works inside of this, because that would be really cool if it did, and it would make our lives very easy. And no, that does not exist. So now I need to find the PowerShell version of getting the SHA-256 hash value of that. Oh, you know what? It's actually not that complicated of a command. I really was thinking that it was going to be a much more complicated command. So the commandlet is called the get file hash commandlet. And I think you do want this capitalization to be very specific. The path is going to be the path to our file. So I should be able to do it like this, where the dot represents our current location, and then the backslash represents the, just getting into this. You could technically also just do this too. If you really want to be like, sure, we could do s:, and then we do backslash, and then we will do donation _ call.txt, and then close that quotation right there. And then we're going to do algorithm, and then we're going to say SHA-256 like that, and then press enter, and boom, there it is. So there's the SHA-256 value. So I'm going to copy this like that, Control C, go out and paste it right here, and there's the value. So now we're going to execute the test and then recalculate that hash value. So I am going to, I really don't even need to leave this location, but I'm just going to leave the location and just go back to the C drive for, I don't know, just because I feel like doing it. Invoke atomic test, and then it's going to be the T, what was it? T005, right? T0005 1. Yeah, that's what it is. So T, let's zoom in for you. T000, what? No, what just happened? Oh, connection error? Why? Why is there a connection error? I have done nothing to make you do a connection error. Okay, here we go. Let's zoom back in here. T123. Why is it not typing? I swear if this crashes, I'm going to get... Okay, there we go. 1. And then this is... I just want to see what it is, right? So show details of this. And it's going to perform a suspicious file action. And the command is just restore PS1. Or that's the cleanup command, actually. So this is going to be the command for this universal suspicious share. So we don't really even get to see what the command is because it's basically just executing a PowerShell script. So that's all it's doing. So, okay, fine. We're going to do that. And we're just going to go over here. And then I'm going to press enter on this. And then it's going to run. And it's going to do what it's going to do. And so then what we're going to do is we're going to do get file hash, very similar to what we did before. And the path is going to be the S location where it had the, what was it? It was the donation, right? Like donation something. What was it called? Donation call.txt. There it is. Donation call.txt is the name of the file. So let's do that. Donation underscore call.txt. And there's that. And then the algorithm is going to be SHA-256 and run that. And look at that. It's a different hash value. That means the text document has been modified, ladies and gentlemen. So we're going to paste that, and that should be the new hash value. Excellent. Okay, so here's the thing, right? Because they even told us to make sure that we do it. So we're going to go up and then go up one more. And for this one, we need to do cleanup and make sure that we actually clean up after ourselves. And just for kind of the hell of it, I want to see if the SHA, does it go back to the original? I think it does, doesn't it? 3CA9. And it does. It actually goes back to the original 3CA9. That's cool. So after we do the cleanup, the hash value even reverts back to its original. Very, very cool. Okay, so here we go. Dump and go. This exercise has been inspired by the T1115 clipboard data technique. And the storyline is that the Purple team aims to simulate storing command line history and hijacking system files for multiple aims, including man-in-the-middle, exfiltration, and trick security product overflow. As a team member, your task is to dump command line history, hijack system files, and hijack system files with given custom atomics, and evaluate the generated artifacts. Experiencing the potential impacts of command line history dumps and system file jacks is the objective here. We have two tests, the history dump and the system file modification. And the questions here go, or what's the note? You can revert the system. Okay, we know that already. The first one is find the malicious history dump file. What is the flag? So we're going to run this piece right here. And there should be some kind of a dump file. And inside of the dump file, I'm guessing sysmon and security logs can help. Okay, so great. So we're going to try to find that dump file and the flag associated with it. And then the second one is find the malicious system file modification activity and what is the flag. And it seems to be for that, I'm just going to run that retrieve flag command just like after each one of these and see if the flag changes for whatever reason. Maybe we'll just be able to get the flag by running that THM log stats flag, maybe. If not, then we'll just go through the logs. Who cares? Easy money. So here we go. Let's go, and the very first thing that we want to do is run T0061. And you know what? Honestly, bro, I feel like maybe we might even find the location of the file without even having to go through the logs, because the details of those things might tell us. Like, that's the hacker mindset right there, buddy. So T0006-1 and then show details. So show me what I got. And so this is the location of the script that's going to run the dump file. So one of the things that I can technically do is I think it's type, right? So if I do type, I think, I'm not sure. So we'll see. Atomic red team /atomics t 0006 and then dmp.ps1. I just want to see if I can find the contents of that. Oh, I can. Look at that. Okay, so this is the contents of everything that's done. And it does look like that there's been a lot of encoding that's taking place. So, yeah, it's going to take me a while to even try to make sense of all of this. And of course, I would have to use CyberChef to decode all of these things, because this is going to be a monster of a document to try to analyze manually, or just obviously I can't decode any of this without using a tool like CyberChef, but there are some things that are over here that are interesting. The variables are all jargon, so you can't even make sense of what the variables represent in this particular case, and then everything has been converted into base 64 encoding, so you can't see anything in plain text. So it would be a very tedious experience to go through all of this and try to decode all of these things piece by piece, although I'm super freaking tempted to do it. So to save time, and instead of doing things manually and going to decode all of these things, I'm going to actually just run the test, and then we're going to go analyze the files, analyze the logs. So first and foremost, we're going to go back here, and the application logs for Aurora are what, non-existent. Well, actually it says there's something here. So where is it? It says number of events is 1, but nothing is presented to me because I think I have a filter of the current log to show Aurora. So I think it's maybe something that's outside of Aurora that's present. So we're just going to go back to the sysmon log files and just look at the sysmon log. And from the sysmon log, let's see if we can actually clear it and find any interesting information after we run the new test, which is the it's the 666, right? 0061. I think that's the first one that we got to run. So let's see, 0061. So here we go. Invoke atomic test T 0061. Press enter. Let's see what happens. It's creating a history dump. Excellent. It's going to do everything that it's supposed to do. Excellent. And it is doing the okay, it did it. And what do I have here? Oh, okay, you know what? This is now the moment to see if that retrieve flag, like the log stats flag, I'm very curious to see if it'll actually get the flag for me. So that would be an interesting experience. So thm-log stats, whoops, thm-log stats, like that, and then flag. And emulation is fun. Okay, fine. Never mind. Too good to be true. Okay. We're going to go back, and I mean, the last few commands that I ran are also going to show up over here, but we do have 11 files over here, or 11 events, I should say, or excuse me, 9 events. So what do we have as the first one? It's the host name. Next one is going to be who am I? Okay, great. All of those are exactly the same. And then new process creation is for atomics. The dump file, or the dump thing, actually was ran. So that's the process that's running. File created is the PS1, this thing right here, and this always happens. So here's another one, which is the DLL. I don't think this is it. And again, I have a freaking connection. I swear this connection error is really just getting under my skin. Okay, so this other file that was created is this DLL file, although I feel like that's not the one that we're interested in. So we're going to go through the next one, and we have a CMD file, and then a process created here, and then another process created, and then another file created, which is again the DLL file. So I'm very curious. And then there's a new event that also even came up while we were going at 26 other events. Holy shoot. Okay, so let's scroll all the way down. We have this file created right here. Okay, so let me see. Maybe there's something else that's going on. So let's see. Let's see if I can find something juicy. Let's see if I can find something good. Okay, so I cleared all of the security logs. So this is where it is, under Windows logs, where application was, and we were looking at Aurora. Right under that, there's security logs right here. So I cleared all of the security logs. I cleaned up the test that we just ran, the 061, and then I reran the test. 061 one more time. And then I came back to the security logs. The security logs had like a massive amount of events. And then so we see that there are several elements here. Obviously, the log clear also shows up in the security logs. The last three right here are the file system. And then when we click through them, one of them right here, this one right here, the object name is analytics.txt. And then the next one is again also analytics.txt. And then we have also analytics.txt. So this is like the one file that came pretty consistently through every single location, and it's the same exact path, and it's a text file. It is not a DMP file. Typically, when you think about a dump file, you think about the extension of dmp.dmp, and that's usually what I also think about as well, and that's kind of what I was looking for. And you know, I was, if I had hair, I would be pulling my hair out essentially. But so in this particular case, it's actually a txt file. So what I'm gonna do is I'm basically just going to type, meaning so I want to print everything onto the screen, and we're going to look at the contents of that file. So the administrator app data spc tmp, and then analytics.txt, and let's see what we get. And look at that, these are actually log files. Yes. So this is the keystrokes have been captured, right? So these are all of the stuff that I've been entering. This is literally everything that I've been entering that has been captured and created and put inside of this dump file. These are all of my commands, literally piece by piece. All of my commands are here. So the very last one, there it is. This is the last one right here, which happens to be the flag that we're looking for, THM, etc. So let's do that. Put that right there. Excellent. Very nice. Very exciting. I'm super happy that was found right there. And then so we can now go back up here and do this, and then do clean up, and that's going to clean that up. And then let's go to the next question. It says find the malicious system file modification activity. What is the flag? So T00062. Okay, so same thing, right? We're going to go back here. We're going to clear these logs right here because I want to make sure that I can generate new events. Of course, the log clear shows up as one of the first events over there, and then we're going to go under operational over here, and we're also going to clear all of the sysmon logs as well. And then we're going to go over here and run the test for 062. So we will do invoke atomic test T0006-2. Let's do show details real quick. I might have to wipe the logs one more time, but here we go. Show details. We have, what do we have? The command is atomic. Again, it's just another script that's going to run. So whatever, we're just going to do this real quick and run the test. There it is. System file modification for exfiltration. And we're going to go to our events here. So let's refresh sysmon. There are 11 events here. The file itself, the most recent one file created is this DLL file right here. We have another file created for command line. These are very similar to the previous set of commands that happened when we did the last one. So, okay, that is not of interest to me. So let's go to the security logs over here, and we have some file system stuff that's been created. So object name, etc hosts, that's the configuration file that was modified. Etc host was modified. Process creation, target object. Let's see the command here, the process name, and this is the full command that has been ran over here. So the question is malicious system file modification activity. What is the flag? So file system, it seems to be the file that was modified was that etc hosts file, right? So let's see if we can do some investigation on that. So we're just basically going to do the same exact thing. We're going to pull up PowerShell. We're going to go look at the contents of that etc hosts file and see what's inside of it. So we will do type, and we'll do C. We're going to go into Windows, System, 32, Drivers, etc hosts. And let's see what's in here. Boo, 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 boo. What do we have? Ooh, look at that. THM1010 John, THM right here. That looks like a flag to me, buddy. So there we go. So the local hostname resolution is handled with DNS itself. Everything else looks fairly normal, right? Except this just one thing right here that is very much the kind of the format of all of the flags inside of TryHackMe, and they do it so that it's obvious to us, like it stands out, and we're like, oh, that's the flag, that's what we're looking for. And it also gives us the final clue that we were actually on the right path. So we found the appropriate event for a file that was created or modified, I should say. The etc host file was modified, and the host file is essentially what resolves IP addresses to domain names. And so there was this IP address, or seemingly this IP address, because that doesn't really look like an IP address. It just has the .10.10. That kind of looks like an IP address, but that was resolved to this flag value right here. So that is the flag that we have here. And there we go. We are officially done with all of our flag captures. So let's just make sure that we do a cleanup of this as well. And we will be done with these exercises. That honestly was pretty painless. I hope that you were able to run all of these exercises with me, and you were able to capture all of those flags with me. And of course, if you have any questions on this, please don't hesitate to drop your comment in the comment section below. But that is pretty much it, my dear friend. We are officially done with the capture the flag exercises for the first atomic bird goes purple exercise. There's another one that comes after this, which is number 2, which I'm just gonna guess that it's gonna be a little bit more difficult than this one. But for the most part, this was pretty fun. It was a nice little exercise to run, and we got a chance to reuse Atomic Red Team and invoke Atomic Test. And there it is. That's it. Officially finished the Atomic Purple Bird test that we just went through. So let me just make sure I terminate this virtual machine as well. There isn't much to explain in this, simply because of the fact that a lot of the lecture elements of threat emulation were covered in the previous video. So this was just us bringing all of those skills together to be able to narrow down the capture of these flags and to be able to kind of find the stuff that we were looking for. So if you did not watch the previous videos, you may have had a little bit of a learning curve going through this video. But if you've seen the last few videos, so the very one right before this one was Caldera, which was also, it's like a graphical interface for running these types of tests, but it's very similar to this overall concept. And then before Caldera, we had the Atomic Red Team, where we were running invoke atomic test in a bunch of different case scenarios, and we were able to capture a bunch of different data and do a lot of things looking at logs and things like that. So if you did go through that video with me, then all of this is just review, and none of it should have been any difficult at all, and you should have had no problem going through this. So hopefully you did go through that. If not, this might have been challenging, but honestly, I feel like even if you didn't go through that, this should have still been fairly easy. I was kind of like running through the commands pretty quickly because we've done so many of them before, but you saw the pattern, right? So we just looked at the details of it. One of the questions was literally the detail was in, or the answer to the question was in the detail for that failed command. So you can just see how easy it is to be able to pull data just by looking at the details of the test sometimes. Like the answer will literally be in there for you. And then it's a good habit to form where you just look at the details of the tests that are being run just so you can see what's going to happen, because the detail of the test sometimes will tell you, hey, listen, if you run this, it's going to shut the system down. So you don't want to run it. You know what I mean? That was actually something that we did run in the Atomic Red Team video when we ran through it. One of them was, don't run the test, just look at the details so you can find out what it actually does, because if you run the test, it's going to shut down the virtual machine and everything. And it's like, okay, all right, well, it's good to know. So yeah, that's kind of the gist of how these whole things work, and this was a pleasure to go through. I think after all of the pauses and everything is edited out, I feel like this video is going to be right around an hour or maybe less than an hour. So it was just fun. I hope you had a good time. I hope you got a chance to get all of the flags and all of the answers yourself. And apart from that, if you have any questions or anything, make sure you drop it in the comment section. If you found any value in this video and you would like to get more videos like this one, I encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel, especially as we finish up SOC level 2, because we're actually getting close to the end of SOC level 2. We have one more video in threat emulation, and then I think there's like 2 modules that are left in total. So we're getting pretty close to the end of SOC level 2. And then there's other videos that are coming out. I already started the CompTIA Pentest Plus playlist, which is just around the guidelines and the outline from CompTIA directly. There's already a Pentest Plus playlist that exists on this channel, but that's based on the stuff that TryHackMe was teaching. And the one that I'm creating right now that we started last week is literally based on the guidelines for CompTIA's Pentest Plus certification, the most recent, the Pt.003 test. So that's already up and running. We're going to finish up SOC level 2, and then we're going to go into AI for cybersecurity, and there's a lot of other great things that are constantly coming out. So I really, really sincerely hope that you do join us in the community so that we can kind of explore all of these things together. And of course, you'll get a bunch of value for free as being a part of the community. So make sure that you like, subscribe, and turn on the notification bell so that you get notified when a video comes out. And if you have any questions, drop a comment. If you're serious about your CySec education and want to get access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. I hope I see you in the Discord chats. If not, I hope I see you in the comment section. And that is it for today. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease. And I'll see you in the next video. Later.